Hello there, this is Mr. Sutton, and this is a lesson on writing exponential functions. Specifically, we're going to model and solve some real-life problems with these kinds of functions when we already know the growth factor. For our warm-up, let's talk about converting percentages to growth factors. Let's say I start with $100. What do I need to multiply that by to achieve the following? 5% increase, 12% decrease. Pause the video and see if you can figure this out. Alright, so for my 5% increase, I basically want to increase from $100 to $105. So what do I have to multiply $100 by to get $105? Well, I need to multiply it at least by 1 to get the original $100 in there. And then I need another 0.05 rather, to get another $5. So I need to add those two things and multiply it by 1.05. Again, the 1 preserves the original amount, and this extra 0.05 gives us that extra percentage. So how do you think we handle a 12% decrease? Well, it's the same idea. We're starting with the original amount 1, but now I want to take away $12 from that. So I have to subtract 0.12, and that would give me 0.88. So in general, if I have a percentage, how do I convert it to a growth factor? Two steps in this. First, divide the percentage by 100 to get a decimal. And then, if you're increasing, add that decimal to 1. If you have a decrease, subtract it from 1. Let's do an actual kind of real-life problem now. Let's say we have an alien blob growing at a rate of 14% each day. If the blob is 2 pounds now, how big is it going to be in 50 days? So first we'll start with our exponential form. That would be AB to the t. And now we need to figure out a, b, and t and just plug it all in. So a is our starting value. So in that case, that's the 2 pounds that we're starting with. And then b is what we have to keep multiplying by. Now, in this problem, we want to grow 14% each day. So if we're growing by 14%, that means that your 100% is getting another 14% added to it. So again, you've got 1 plus 0.14, or 1.14. And now for the time, the t, that's going to be this 50 here. So let's rewrite the formula first off. We've got 2, our starting value, times 1.14 to the t power. So this is a function for any amount of time for this blob. And then we'll actually plug 50 in there for t and see what that comes out to. And you will need the calculator for this one. So on my calculator, I've got 2 times 1.14, and then I pressed my exponent button, and 50. Gives me 1400.5, and that'll be pounds. And that is one heavy blob. Here's another example. Pause the video and see if you can do this one on your own. All right, so let's see what we came up with. So we have this element ninium. It's kind of made up, but it could exist in some universe. That's decaying at a rate of 9% per hour. We've got 34 kilograms now. We want the amount present in 3 hours. So standard exponential form. A value is the 34 kilograms you're starting with. The B value, we're decaying at a rate of 9% per hour. So that's going to be 1 minus 0.09, or 0.91. So plugging that in, we've got 34 times 0.91 to the t power. And we want to know the amount present 3 hours from now. Now you have to make sure that the units here match up your rate of change units. So this is 9% per hour, so 3 hours we are allowed to plug in the t value 3. But you have to be careful. Every now and then they'll say like 3 days and you have to make that conversion. But here we can just plug in 3. Calculator time. So there we are. Grand total of 25.6 kilograms. We'll do one more problem. Pause the video and see if you can get this one. So price of a video game system increases 13% a year. If the current system costs $600, how much was the newest system 5 years ago? So this is a little bit different because now we're asking about something that happened in the past. But let's start it the same. So we've got AB to the t, and we know this is an exponential problem because we've got this percentage increase every year. So we should be thinking in the back of our heads, this means I'm going to have to multiply by something every single year to deal with these percentages. So that's how we know it's an exponential function, is that repeated multiplication. So a value, the current system is $600. b value, we have a system that's increasing 13% a year, so that'll be 1.13. So here's our overall function, 600 times 1.13 to the t power. But now we have to be careful, since we're asking about 5 years ago, back in time means we're going to have to use negative t values. So this is going to be 601.13 to the negative 5 power, calculator time. And that gives us a price tag of $325.66. So one thing you can do on all of these problems is at least check your final answer for reasonableness. A current game system is $600 and it was increasing every year. So if you're asking about something 5 years ago, you should end up with a value that's lower than your initial value. And same for the other problems we dealt with. Anyway, that's all for now. Until next time, this is Mr. Sutton signing off.